Welcome, ladies and gentlemen, to another exciting episode of the Maths videos by Mr. Moya. Okay, so today we're looking at this, and our hope is that I just created a checklist there. So the idea is to try and introduce math operations, but using baby steps, like straight from addition, like that's where it really began, and hopefully we'll be able to move on to everything else that you have came across, including indices and logarithms and so on. But I think for this particular video, we'll just end off a bit early so that we can then be able to build up on logarithms in another video, expressly on that. Now, just to begin off, it's like we want to imagine where mathematics began. Okay, so I think everyone will agree that back in the day when we used to do the hunting and gathering, okay, we would occasionally have to accept either a payment in the form of either cattle or something. So in other words, we will add material to what we had. So I believe that the first operation or math operation that was brought to men was more of addition. So we're going to begin with addition. So really, we have addition as being the first operation. And to me, this is the key or the pivotal operation more than anything. So I believe that the whole entire math is founded on the basis of addition. So in other words, we can express everything else in terms of addition. Okay, I think I'll show you just now exactly what I'm talking about. Okay, so that's the introduction to addition. So we normally learned how to add. That's why it's easy for people to add, and it's a bit tad difficult for people to attempt to do other operations. Okay, because addition comes natural to us. So the first operation that we learned was addition. Okay, but then of course we learned to accept things. But what was the reverse situation? We also learned to give away things. That's when we had to learn the inverse operation, which in this case is going to be subtraction, which is when we remove things. Okay, and what then happened was we then had to also add the same number a couple of times. Now, if you think about it, if you add the same number a couple of times, that's what brought about multiplication. Okay, that's what brought about multiplication. And once we learned about multiplication, we also had to learn the inverse process, which we call division. Okay. And again, once we learned how to multiply, we also had to multiply the same number over and over again. And what did that give us? That gave us what we call powers or indices nowadays. Okay. And once we learned about powers or indices, we had to learn the inverse case, which is roots. Okay, so if you notice, I'm just going to change the color momentarily. This here, these guys right here, all these operations right here, come natural to us. If I ask you what is 2 plus 2, it's easy for you. If I say it's 2 times 2, again, that's kind of natural for you. If I say 2 to the power 2, it's easy because you're forward thinking. But then if I ask you to do the reverse procedures, which I'm going to try and use a different color for, if I ask you to do the reverse procedure, it's pretty uncomfortable. If I ask you to subtract a 10, we all know how negative signs really annoy us. And we end up making mistakes because we see a negative sign. And we also know how much we do not like fractions. And that's exactly what this sign really means. This sign means something over something. So it's really just a fraction notation if you think about it. Okay, so that's one of the reasons why we don't like fractions, because it's like a reverse procedure. Same thing with the roots as well. If I ask you to find the square root of 27, so the cube root of 27, or the fourth root of 64, if I ask you to find 4 to the power 4, you can easily say it's going to give you, for example, a 256 or something. But if I ask you to find the fourth root of 256, that will be a bit tad difficult for you, again, because it's a reverse procedure. So it's a bit more like when you learned how to walk. Okay, It's easy once you begin to learn how to walk forward. Even up until now, if I ask you to do the reverse procedure, which is walking backwards, you will struggle much, okay? And so that's why people tend to dislike um, uh, this kind of operations right here. They tend to dislike subtraction, they tend to dislike division or fractions, they tend to dislike, again, finding the root. But these are very powerful. I think these are more powerful in advanced mathematics, like the grade 11 and grade 12, so the AS and the A2 levels for Cambridge, or your higher level for IB, and you use those expressly and you have to master those to a great extent. But just for this year, I think that should be just about okay. So in other words, you should remember that the opposite of addition is subtraction. The opposite of subtraction is addition. The opposite of multiplication is division. The opposite of division is multiplication. The opposite of powers or indices is roots. And the opposite of roots are powers or indices. Okay, where are we going to use those? We want to look at the application. So we're done with the first two, the introduction of your addition, and we're done with the introduction to inverse operations. Now we want to see where the application of the inverse operations comes in, particularly when it comes to the subjective formula. Okay, but let me just begin with something quite basic. If I give you numbers, okay, if I give you 2 plus 5 is equals to 7, okay, normally, if I want to move a number over to the other side, there's something that we need to first of all deal with. The equal sign, this equal sign, is what gives us the name equation. Okay, so you know you're dealing with an equation when you have a statement with an equal sign. Okay, and again, if you have a statement with an equal sign, it means that the left hand side is balanced with the right hand side. So if you had weights, then what's on the left should balance with what's on the right. Okay, and how do you deal with with the equations? Here's a rule of thumb. Whatever we do on the left hand side, we must do on the right hand side. Okay, right. So that's a rule of thumb. Very important whenever you're dealing with equations. Whatever you do on the left hand side, you do on the right hand side. But I'm going to show you cases again of how we're taught the maths without us having to do this particular rule. But the implication is actually because the rule was followed, but we're just looking at the result of following the rule. We're going to look at that just shortly now. And again, there's something I need to stress right quick before we get into the 2 plus 5 equals to 7. Whenever you have fractions again, so this is for equations, whenever you have fractions, let's say you have an A over B, okay, the rule of thumb is for you not to change the fraction, whatever we do on the numerator, which is our A, apologies, on the numerator, A, we must do on the denominator. And this is expressly for multiplication and division, okay? It's expressly for multiplication and division. With addition, it can change, addition and subtraction, it can change a whole lot of things. So notice how this here fall in the same category, okay? And this here kind of fall in the same category. This here kind of fall in the same category, right? And you'll notice how if you want to crossbreed between this here, or use or mix them, then you have to invoke your, so it's mostly when you are crossing between this that you have to invoke that. So if I say to you 2 plus 3 minus 4, I can do them in order, no problem. But if I have to say 2 plus 3 times 4, then I have to invoke weirdness. Same thing, if I say 2 times 3 divided by 4, there is no difference, okay? I will just write it here, 2 plus 3 minus 4. There's no difference if I put the brackets on this one first. The result is going to be the same with if okay, my eraser's acting up. It's pretty weird. 2 plus 3 minus 4, like that. Similarly here, if I say 2 times 3 divided by 4, there's no difference to me going like 2 divided by 4 times 3. It's going to give you exactly the same result. And I think the same would follow with powers and roots, because you will remember the law that 2 to the power of 3 over 4 can be expressed in two ways. It can be expressed as either 2 to the 1/4 and a cube, or it can be expressed as 2 to the 3 and then 2/4. Okay, so in other words, we can begin with the root and then the power comes next, or we can begin with the power and then the root comes next. Again, they're interchangeable, but once you begin to mix them, the different levels of maths operations, the basic maths operations, then you'll have to invoke BIDMAS. Okay, again, just for those who may be a bit new to what BIDMAS may be, let me just expand on that here. It's an order in which we apply maths operations, and we normally say that you deal with terms in brackets. Be very careful. Brackets does not mean just brackets for the sake of it. It means simplify whatever is inside the brackets first before you move on to any other operation. The I, some usually even use an O. So the I stands for indices, okay? Or some may prefer to go with powers. But I guess for readability, we chose the I. And then the D goes for division, multiplication, addition, subtraction. Like that. Okay, now coming back to a 2 plus 5. As long as we know that whenever we have an equation, whatever we do on the left, we do on the right. Whenever we have a fraction, whatever we do at the top, we do at the bottom as well. Usually only for multiplication and division. Then we haven't changed anything about the fraction. Okay, now coming back to the 2 plus 5 equals to 7. Now I want you to notice something. If I want to remain with the 2 on the left side, okay, what I will need to do, I'm going to use a different color. I need to invoke the opposite operation. So notice what I'm going to do is I'm going to go minus 5. Don't know where the 3 came from. On both sides, because it's an equation, what I do on the left, I do on the right. Notice what that is meant to do. It's meant to cancel that right there. So what I'm left with is a 2 equals to 7 minus 5. So at school, when we're taught this, we're taught that it's like you took the plus 5 and then you moved it to the other side. So effectively, it looks as if you've just transferred it and it just changed sign. So you've taken the opposite sign or the opposite operation to it when it moves to the other side. Again, let's take another look. Here I'm going to make it quite quick. So you got 8 minus 5 equals to 3. So if I want to remove the minus 5, one thing I need to ask myself is, what is the 5 doing? The 5 is subtracting, okay? So if the 5 is subtracting, to move it to the other side, I need to add the 5 on both sides. So this effectively cancels that 5. So I'm left with 8 is equals to 3 plus 5, which is correct. Similarly, I've got an 8 minus 5, okay, equals to 3. If I want to move the 8, I need to subtract the 8. Why? Because the 8 is adding, okay? Because it's a plus here. It's a silent plus. It's a plus 8. So to remove it, I need to use the opposite operation, which is subtracting 8 on both sides, like that. So that'll give me minus 5. So this here, cancel. Minus 5 is equals to 3 minus 8, like that. So we more or less use reverse functions to solve rather to transfer material or to transfer numbers over the equal sign. That would even go as well for multiplication. So if I've got 2 times 5 is equals to 10, to remove the 5, I would just need to divide both sides by 5, because the operation of the 5 is multiplying, and the operation of that's opposite to multiplication is division. So I need to divide by 5, and as usual on both sides. And I'm left with 2 is equals to 10 over 5. Same thing again. If I have 20 divided by 4 is equals to 5. What is my 4 doing? It's dividing. So to remove something that's dividing, remember, to remove something that's dividing, here, we multiply. So that's express what we're going to do there. So we're going to come down there, and we're going to multiply by it. And that's on both sides. that allows us to cancel that. Then we have 20 is equals to 5 times 4. Similarly again, if you now have powers, let's say I got 2 to the power 3 is equals to 8. Now, to remove a power, if you remember what the opposite operation to powers is, the opposite operation to powers is roots. So it means I need to introduce the root of whatever the power is. So this is 2 to the power 3. So it means I need to introduce a cube root. And guess how? On both sides. So that will enable me to cancel this 2 here. So I'm left with 2 is equals to the cube root of 8. Okay. Same thing. If I have, for example, the fourth root, or rather the cube root of 64 as being equals to say 4, and to remove this cube root, to remove a root, I will need to raise it to the power itself. So that will give me this, we'll cancel off with that. That 64 is equals to 4 to the power 3. So that's how you want to do some of these operations right here. So that kind of goes for, I think, this part of our trying to make subjective formula. Okay, so that's our application of the inverse operations. Now, if you're trying to make subjective formula, let me just do it this way, very quick. Subject of formula. Now, when you want to make something subject to formula, it's like you're doing the reverse of bead mass, but I will not go into that because I think there's an easier way to do it. Imagine that when you're making subject to formula, what you're doing is you're zooming in to a particular letter. Let's say you're given a 3 x minus a squared equals to y, right? So we want to make, for example, a subjective formula. So make a sub of formula. And how we do it is we want to zoom in. I'm going to use a different color. We want to zoom into this here. So my idea is to start with number or operation furthest from your letter that you intend to make subject to formula. Again, imagine it's like you're trying to get to the middle part of an onion. Okay? You do not begin by just peeling the inside part. You have to begin by peeling the outside parts until eventually you get to exactly what you're going to. So I call it the onion peel approach, or the onion peel principle. So I'm trying to zoom into my A. So what I need to do is to start with the furthermost outside on the side where my A is, not just anyway. The Y is already on the right side. I'm not worried about that. I'm worried about separating or stripping off the onion peels on the left side. So just to take that off, that's going to be 3 x minus a squared equals to y, okay? And the furthest I can see is the 3. So what's the 3 doing? The 3 is multiplying, so to remove the 3, I'll need to divide both sides by 3. So that will then allow me to get my x minus a squared is equals to y over 3. And then what's the furthest operation? I can see I definitely cannot get into the x because the x is adding, but it's inside the brackets. So if you notice, the furthest operation will be to remove the power, okay? And that power is a square. So I need to use the root to undo that. If you remember, we said that the opposite operation of powers is root. That's why I would need to use the square root. I want to write a power half, but I think for consistency, let's just use the square root like that. If you want, I can put the 2 there, not necessary though. So because it's an equation, I do it on both sides, okay? And I will end up, this cancels off with that. So that will leave me with just x minus a. Notice how I leave the brackets out because it's no longer necessary to raise that bracket to a power 1. So it gives me the same thing. And that gives me equals to the square root of y minus 3. And that's the square root. Now I need you to be careful. For advanced level subjects, you need to put a plus or minus square root of y minus 3. But for basic levels, then you just need to just assume that your square root is always going to be positive. And now, because I'm trying to make my a subjective formula, okay, here is where I want you to be careful. You could try and transfer the x to the right side, okay, but that leaves you with the negative a, and then you can divide, no problem. But I prefer to just take my a so as to make it positive to the other side. Now, how do I get my a to the other side? I can add a on both sides. Or I can just do what we do at school. just transfer it to the other side, then it becomes a plus a. So that gives me x is equals to square root of y over 3 plus a. Notice how I lift up the 2 on the square root sign, because it's not necessary. Any other root you'll have to show, but for the square root, it's by default known that if you have the square root sign, then it's automatically by default a 2. And then what do I need? Now I need to transfer this to the left hand side, okay, because I want to be left with just the a. So that gives me an x minus my square root of y over 3 is equals to a, and expressly I can then write my a is equals to x minus the square root of y over 3. That's my final answer. So that's my a expressed in terms of everything else. Okay, thank you very much. And let's look at what else do we need to do. Now, I just need to stress something, that understand that when you're solving an equation, what you're really doing is you're making x subject of formula. Okay, that's why if I gave you x squared minus x minus 6 equals to 0 and I asked you to solve for a, you cannot solve it, you cannot do anything like you used to where you factorize and then equate and then divide, because it's going to be a bit difficult to isolate the x there. So you can make the x subject of formula. That's why the only way you can solve this is to either complete the square or use the quadratic formula, in other words. Now, the completing the square, the main idea behind completing the square is to enable you to isolate your x, and then you can be able to then make subject of formula for that x. That's the reason behind completing the square method. All right, so I think that just about tops up everything that we wanted to look at within this particular session. Thank you very much for having joined me, and have a fantastic day. Goodbye.